Welcome to chapter 3. So, in this chapter, we'll talk about functions and graphs. So, let's start with section 1 functions and how to notate functions. So, after you complete this section, you should be able to determine whether a relation represents a function, find the value of a function, determine whether a function is a one-to-one function, and use the vertical line test to identify functions, and finally, graph the functions listed in the library of functions. So, let's start with a relation. So, what is a relation? So a relation is a set of ordered pairs. So remember this question, this relation is a set of ordered pairs. It's just a simple order. For example, A comma B written in a set can be considered a ordered pair. So the set consisting of the first components of each ordered pair, we call it the domain. And the set containing the second components of each ordered pair, we call it the range. For example, let's say if I have in a set A comma B, C comma D, E comma F. So then this represents a relation. So this represents a relation. Now for us to represent one to be a relation, so first thing is it has to be an ordered pair, which means that there has to be two values. And the first values of each of these is called as the domain. We call it the domain. And the second part of the ordered pair, we call it the range. So depending on the idea of what can be considered a relation and what is a function, let's take a look at this diagram here. So in this diagram, notice that the first part represents the input, which is the domain, and the second part represents the range. So each input should have an output. So that is the idea behind the function. Specifically, every input should have a unique output, or we can also write it as every domain should have a unique range. So every value in the domain should have a unique range. We call this a function. So a set can be a function but not a set can be a relation but not a function. For example, in this, if you notice that each input points to a unique output, even though Q and R here are also pointing to the same input, but they are not having two outputs from one another. Understand that one input cannot have multiple outputs. So this is the prime principle in functions. So one input cannot have multiple outputs. So again, here each input has a unique output. This can also be considered as a function. But let's look at the last example. P represents Q, X, and Q goes to Y, Q also goes to Z. So one input has two outputs here. So this here is not a function. So not a function. So this is how we determine a given function, a given relation is a function or not. So one input cannot have multiple outputs, and every input should have a unique output. So that's the way we determine a function. So a function is a relation in which each possible input value leads to exactly one output value. So we say that the output is a function of the input. So the input value here always makes up the domain. The output values should always make up the range. Now, each value should be utilized in both a domain and the range. So all the values should be, so for it to be called a function, all domain values must be utilized. So all domain values are to have a range, and each domain value must have a unique range. So each value should have a unique range. So how to identify a given relationship is a function? So these are the steps. Number one, first identify the input, identify the output. Third, if each input value leads to only one output value, classify the relationship as a function. If any input value leads to two or more outputs, do not classify that relationship as a function. So this is the idea behind how to classify one as a function and a relation. So let's try an example. So they're asking us to determine whether the relation that is given is a function or not. So there is a coffee shop. The coffee shop menu shown below consists of items and prices. Now the first question is price the function of an item? And the second question is the item the function of a price? So whenever you say function of, the item here represents the input, the price represents the output. So to make it easier, what we can do now is write it down in such a manner. So write it down like this. So now notice that for each given item, for each given plain donut, there is a price. So that is 1. But notice that chocolate donut and jelly donut here both have the same price, which means that you can point this also towards the same input. Now this is one single output. So remember that this is input here. This is the output here. Now there is two inputs that are having the same output, but one input does not have two different outputs. That's the main representation here. Remember the principle here. One input cannot have multiple outputs. So there is one input cannot have multiple outputs. So here it represents that each one of them. So if you write it down like this, let me write it as plain donut, jelly donut and chocolate donut, 149 and 199. So plain donut is 149, jelly donut is 199 and chocolate donut is 199. Notice that one input will not point to two outputs here. So this is the input part, this is the output part. Now we can say that this is a function, because if you just look at the input part, it only has one arrow that is going from that particular input. That's it. That's the only thing that you need. You just need to have one single value going from the input. It can point to multiple outputs, but a given input, one single input cannot have multiple outputs. That's the idea here. But two inputs can have the same output. So that's the principle. Let's look at the second one. Is the item the function of a price? So here in the second problem, this is the input and this item is the output. So let me write it down, the price here. So the price and item. So this is the input and this is the output. Price, you have 149, 199. You have plain donut, jelly donut and chocolate donut. So this is the diagram when you write it in the reverse. Now this is the diagram that you see here. Notice that one input here, which is 199, results in two different outputs. So which means that this is not a function. One input cannot have multiple outputs. Remember here the two principles. One input cannot have two outputs. So two or more outputs. And two inputs can have the same output. Remember, these 2 points are very important. If they look at it at once, then it might be confusing, but notice that one input here can have two outputs. So which means that one single input cannot have two different outputs, but two different inputs can have the same output. For example, this is the example here. So two inputs can have the same output. That's the difference between these two. Now let's look at the next problem. Here they are asking us, is the grade point average the function of a percent grade? So percent grade is the input here, grade point average is the output. So this is the input and this is the output. Now there are multiple inputs here ranging from 0 to 56 which can point to the same output 0. Again, the simple point here, one input can have two outputs. So 0 to 56, all of them are pointing to the same value, which means that two or more outputs are pointing to one input. Sorry, two or more inputs are pointing to one output. Now, the principle, remember the principle here, two or more inputs can have the same output, which means that all these can have the same output. So, here, two or more outputs, sorry, two or more inputs have the same output. So which means that this is a function. So when you write it like this, for example, let's say 0 to 56, both are pointing to the same value 0.0. In the same way, 57 to 61, both are pointing to the same value 1.0. So this is okay because all of them there is only one arrow going from there. Let's look at the reverse. The reverse is percentage grade, a function of grade point average. So here the grade point average becomes the input and the percentage grade becomes the output. But notice here in this reverse part, so this is the input and this is the output. So for example, let's take the grade point average in the input part, so 0, 0.0, 1.0, 1.5. Let's take a simple example part. 0, 1, 2 and so on until 56, and you have 57 and so on until 61. 0 points to all these values. There is one input having multiple outputs. So this is not a function. So the answer for this is not a function. So if you remember the two main principles, so one input can have two or more outputs. Two or more inputs can have the same output. So that's the principle behind function and how to determine whether a given value is a function or not. So now pause the video right here and try to see if you can solve this and find out the answer for both A and B. So in the A part, this is the input, this is the output. Here, this is the output, this is the input. So use this principle now and try to solve this problem. So pause the video right here and try to solve this problem. So next let's talk about the notation. So how do you represent a function? The representation is generally notated as y equal to f of x. It represents that y is the function of x. So here x represents the independent variable or the input variable and y represents the dependent or the output variable. So let's try to use this example here and let's try to see if we can interpret this. So a function n equal to f of y gives the number of police n in a town in the year y. So what does f of 2005 equal to 300 represent? So n equal to f of y says that there are n police officers in a town in year y. If that is the case, then if you want to interpret f of 2005 equal to 300, remember that anything that's written in the bracket is x, anything that's written out is the y. So here 300, it means that there are 300 police officers in a town in the year, what is in the bracket, 2005. So this is how we can interpret the function. So in the same way, now try and represent this. So they're asking you use function notation to represent a function whose input is the name of the month and the output is the number of days in that month. So input x here should be the name of the month, and the output y should be the number of days in the month. How would you represent that? So for example, let's consider the name of the month is n and the number of days is d. Then we would write it as y equal to f of x. Y here is d equals f of n. Right, so this is the notation that you would have written. So now use this same principle now and try the next example. So they're asking you to use the function notation to express the weight of pig in pounds as a function of its age in days. Now, which is which? So weight of the pigs is y, function of in age of days is x. So x represents the age in days and d, and y represents the weight in pounds, w. So pause the video right here and try to see if you can write it in the form y equal to f of x. Next, let's try and understand how to represent functions using tables. So given if you have an input value, so table of input and output, so you have to determine whether the table represents a function. So the first thing we want to do is identify the input and output, and number two, check to see if each input value is paired with only one output value. So if so, the table represents a function. So let me do the first example. So 2 gives 1, 5 gives 3, 8 gives 6. So all of these are unique from one another, so which means this is a function. Let's do the second one. Minus 3 goes 5, 0 goes 1, 4 goes 5. But notice that both these values are the same, and here two inputs are giving the same output. So which means, remember the principle here is that two inputs can have the same output. So with that principle in, so 4 means 4 also goes towards 5. This is also a function. Next, in the next one we have 1 goes to 0, 5 goes to 2, and there is another 5. So let me rub it out. 5 also goes to 4. Notice that this value gives two outputs. So this is not a function. So this is not a function. So this is how we can determine whether a given value is function or not a function from the table. So choose the input. If every input has a unique output, that means it's a function. If one input gives more than two outputs, so more than one output, then that's not a function. So that's the idea behind function or not a function. Next, how do you find input and output values of any given function? So how do you evaluate functions? So given the function, so first thing that we want to do in the formula, how to do it? First, replace the input variable with the formula, in the formula with the value provided, and finally calculate the result. So they have given us the function h of p equals p square plus 2p. They are asking you to find h of negative 4. H of negative 4 becomes, in place of p, replace negative 4. So negative 4 square plus 2 times negative 4. Remember again, we are basically replacing what is the value of p in the function with the value itself. So negative 4 square becomes 16 minus 8, that gives you 8. Next they are asking you h of a, again in place of p replace a, so it becomes a square plus 2a. In the same way, h of minus a becomes, in place of p write minus a, so minus a square plus 2 times minus a, so that becomes a square minus 2. So with that in, try doing the second problem on your own. So pause the video right here and try to solve the second problem. They have given g of m equal to root m minus 4. So find g of 5.
Alright, in the last problem we saw the output parts. Now let's look at the input. They have given us the function f of x equal to x square minus 3x, but they have asked us to solve for f of x equal to 4. So f of x equals 4. So in place of f of x, replace it with the function, which is x square minus 3x equals 4. So which can also be written as x square minus 3x minus 4 equals 0. Now solve for the value of x. So x minus 4x plus x minus 4 equals 0. This is how when you factorize it. So x times x minus 4 plus 1 times x minus 4 equals 0. So x plus 1 equals 0, x minus 4 equals 0, x equals 1, x equals 4. So these are the two values that you can get. So use the same principle now and try to solve the second problem. They have given us g of m equal to root m minus 4. So g of m equal to 2. So root m minus 4 equals 2. How would you solve this? A square on both sides. So m minus 4 becomes 4. So m becomes 4 plus 4. That becomes 8. That's it. So this is how we can find input and output values in a formula. Next, let's evaluate functions expressed as formulas. So how do you do that? First, solve the equation to isolate the output variable on one side and on the one side of the equal sign, and the other side as the expression that involves only the input variable. Second, use all the usual algebraic methods for solving equations such as adding, subtracting the same quantity or to or from the both sides, multiplying, dividing by the same quantity. So use this principle and finally find your answer. Now let's try the example here. So consider the relationship 3r plus 2t equals 18. They are asking us to write the function as r equals f of t. Remember that one side there should only be r, everything else should be on the other side. Now use this principle here. 3r plus 2t equals 18. How would you solve this now? We only need r. So push everything on the other side. So this is 3r, keep it on this side. Plus 2t, if it goes on the other side, it becomes minus 2t. R becomes 18 minus 2t by 3. So this is the form of r equal to f of t. If r equal to f of t, we can write that f of t equals 18 minus 2t by 3. That's the principle. Now they are asking us to evaluate f of minus 3. How will you find f of minus 3? In place of t, put minus 3. So f of minus 3 becomes 18 minus 2 times minus 3 by 3. So 18 plus 6 by 3, that becomes 24 by 3, which is become equals to 8. Now let's try the second one. They have given f of t equal to 2. So this entire value f of t equal to 2. So f of t equals 18 minus 2t by 3 equals 2. Now we can remove f of t from this equation. Now try to find the value of t here. 18 minus 2t equals 6. 18, sorry. So push 2t to the other side. Push 2t to this side, push 6 to this side. So 18 minus 6 equals 2t. 2t equals 18 minus 6 is 12. So t equals 12 over 2, which is 6. So if f of t equal to 2, then t is equal to 6. So which means that f of 6 equals 2. So this is the answer. So use the same principle now and try to find this problem here. Remember that only y should be on one side, everything else should be on the other side. So pause the video right here and try to express y as a function of x. Next, how do you evaluate a function in tabular form? So when you have a table, how would you find the value? So let's try to find first thing. How do you find it? Find the given input in the row or column of the input values. Second, identify the corresponding output value paired with the input value. And third, find the given output value of the output values, noting every time the output value appears. And number 4, identify the input values corresponding to the given output. Next, so first question they have asked us, evaluate g of 2. Here remember that 2 represents the input. So they have given us the table n and g of n. So n is the input and g of n is the output. So they are asking us to g of 2. So yeah, wherever n is 2, find that g of n. So for 2 the value is 6, so g of 2 becomes 6. Next they have asked us g of n equal to 7. So find out in the output where the 7 value is. Whatever the n value for that output, that becomes the answer. So n here is 3. So this is how you can evaluate a function in its tabular form. Next, finding function values from a graph. Again, the same principle. Whatever the value that you are using inside the bracket is the x-axis value. Whatever the value that you have output is the y-axis value. Now for the x-axis value, find the y-axis value. So for x equal to -1, so for x equal to -1, find the y value where it corresponds on the graph. So where the line cuts. So this is the point where it cuts. So for f of -1, the value is 4. This is how we can find the value. Next, f of x equal to 0. So which means that for the output 0 on the y-axis wherever 0 is, find the x value. So for the y-axis where 0 is, so this is the y-axis part. You are finding the x value. The x value is 1. So x is 1 here. This is how you can evaluate functions from a graph. So whenever you are finding the value directly of the function, use the x-axis value and see the intersection point on the line. If you are finding the y value, from the y value if you want to find x, so use the y value and draw a horizontal line. Wherever it intersects, that becomes your point. So when you want to find the y value, draw a vertical line. When you want to find the x value, draw a horizontal line. Wherever it cuts on the graph, that becomes your answer. Next is one-to-one functions. What is a one-to-one function? So a one-to-one function is a function in which each output value corresponds to exactly one input value. So there are no repeated x or y values. So this is where one input equals one output. So no extra inputs, no extra outputs. So no repetitions. So let's try the first example. Is a balance of a function, is the balance a function of the bank account number? Obviously, because bank account number is the input, balance is the output. Now, is it possible that every single bank account number has a unique balance? Obviously, every single bank account number will have a unique balance. So that's where the difference comes in. The second question is the bank account number a function of balance? Now, the balance is the input, the bank account number is the output. Now, this is the question, is it a function or not? No. This question comes to the point is that every balance that you have in your value, you cannot have two different balances that give you the same account number, because every single bank account number will have its own unique balance, or every single balance will have its own unique account number. But the problem comes back to the question, there can be many account numbers that can have the same balance. For example, there can be 3 different bank account numbers that have the same balance as $0, which means that this input here has multiple outputs. This is an example of not a function. Remember that one single input cannot have multiple outputs. Now let's look at the first example, a single balance. So is the balance a function of the bank account number? There can be multiple bank account numbers that can have the same $0 balance. For example, this is an example of a function, but this brings up the question, is it a one-to-one function? No, because each individual bank account number does not have a unique balance. There can be chances where multiple bank account numbers can have the same balance. So this is where the difference comes in. Now, so use this principle and try the other 2 examples. So try this example. So if each percentage grade earned in a course translates to 1 letter grade, the letter grade is the letter grade the function of a percentage grade? If so, is the function 1 to 1? So pause the video right here and try to solve this problem. So the best way to check whether a given graph is a function or not is to use what we call the vertical line test. What we do is, how do you find the vertical line test? So given a graph, so use the vertical line test to determine if a graph represents a function. So what is the first step? Inspect the graph to see if any vertical line drawn would intersect the curve more than once. So remember that when you draw a line once, it should only cut the graph once. So if it cuts more than once, it's not a function. If it cuts once, it's a function. So if it cuts more than once, not a function. If it cuts once, it's a function. So if there is any such line, determine the graph does not represent a function. So that's the idea behind these two things. Now, let's try and understand using this problem. Let's try to see if we can draw a vertical line. Now on this, wherever I draw a vertical line, notice that it only cuts on one single point. So which means that this is a function. Let's try the next one. Here, even though there are points where if I draw a vertical line, notice that at this exact point, let me draw it in red, at this exact point, notice that it's actually cutting at two different points on the same line. So which means that this is not a function. Next is this function here. This might be somewhere you might think that this is the function, but notice that both are actually going towards infinity, which means that they are not intersecting at any single point, which means that this is also a function. Right? Remember that just because you draw a line at this point exactly, it doesn't mean it's going to intersect. Notice the arrows there. The arrows represent that they are going towards infinity, which means that they are not going to intersect at that particular line. So that's why we can say that this is a function. So pause the video right here and try to see if you can figure this particular graph is a function or not. So the next one is the horizontal line test. So once you do the vertical line test and you are sure that a given graph is a function, we can use the horizontal line test to determine if a graph represents a one-to-one function. So inspect the graph if any horizontal line drawn would intersect the curve more than once. So if there is such a line, then that function is not one-to-one. If it cuts only the graph at one point, then that is a one-to-one function. Let's take a look at these two graphs. So if you draw a horizontal line on this graph, notice that at some point it cuts more than once. So this is an example. So this is not one-to-one. Now on the other graph, let's say if I draw on this point here, anywhere if I draw a horizontal line, notice that at any single point it only cuts one single point. Right? It does not consider any two single points there. So this is an example of a one-to-one function. Remember that we can only do the horizontal test after you do the vertical test. So first find out whether it's a function or not, and then judge whether it's a one-to-one or a not one-to-one function. So try this problem. So pause the video right here and try to see if this problem here represents a function first, and second try to see if it's a one-to-one function. So let's try and find. So I'm going to show you some functions so that we can use this as toolkit functions. So when you see this function, you should be able to recognize which function it is. So let's start with number one, a constant function. So a constant function is a function that does not take in, so f of x equals c. So the c here represents any constant. Here the constant here, the value is 2. So we can say that this is a constant function. Next, the second one is an identity function. So what is an identity function? So identity function is where we can write f of x equal to x. So this is a graph that shows you the common face of an identity function. It's a line that passes through the origin, and that cuts the origin under straight line. So here f of x equal to x, this function. So remember the identity function. So the next one is the absolute function. So absolute function is written as f of x equal to mod x. What does mod x mean? X is, so mod x equal to plus x when x is greater than 0. It's minus x when x is less than 0. So this is a piecewise function, so which means that it takes into two parts. And this function, we can write it this way. This is the graph of absolute function. So remember that all the the f of x values are always positive. That's why it's always above the graph, never below the graph. So that's the idea behind an absolute function. So notice that even if it is negative value, it becomes positive, minus x here. 2 is 2, negative 2 also becomes 2. So that's the idea behind an absolute value function. The next one, so this is an example of a cubic function, f of x equal to x cube. So this is the example of a cubic function, f of x equal to x cube. So remember the case that it looks this way. We're going to come back to these figures again and again, so just so that you remember. Now next. So the next one is what we call the reciprocal function. So the next one is the reciprocal function. So reciprocal function is basically f of x equals to 1 by x. So this is the reciprocal function and how it looks like. Now let's look at the next one. So the next one is a cube root function. So this is f of x equal to cube root of x. So this is how the function looks like. Now the next one is the quadratic function. So quadratic function is f of x equal to x square. So this is what a quadratic function looks like. Again, quadratic function looks similar to that of absolute value, but here it squared the value. So which means that it is still positive, but it squared the positive values. So remember these values. So this is how the quadratic function looks like. Next, let's look at reciprocal squared. So reciprocal squared is f of x equal to 1 over x square. So this is the graph of a reciprocal squared function and how it looks like. So this is the example of a reciprocal squared function. Let's look at the last one, a square root function. So square root function is f of x equal to under root x. So this is what the function will look like. Right, so this is f of x equal to root x and how the function looks like. So notice in the square root there is no negative because square root of a negative value is infinite imaginary number, so we do not write any negative values. So it's only in the positive plane. So we do not have any negative values. You don't get negative values as well as you don't use negative values as the x value. So that's the reason why it's only in the positive plane. So this is the idea of a square root function. So those are all the basic functions. So let's revise once back again. So the first one is a constant function, which is a straight line function. A constant line, a horizontal line is a straight constant function. The second one is an identity function, which has a slant line passing through the origin. Next one is an absolute function, which is an absolute value, which is always the positive f of x value, and this is how the function will look like. Next one is the cube root function, cube function. So it looks this way. Next is the reciprocal function, this is what it looks like. Next is the cube root function, this is what it looks like. Next is the quadratic function, and this is what it looks like. And next is the reciprocal squared function, and this is what it looks like. And the last one is a square root function, and this is what it looks like. So this is your toolkit of functions. You can find it in the textbook. So try to use the textbook and memorize, try to understand these functions and try to memorize them, so that if you remember the shapes, it becomes easier in the coming lectures to continue and talk more about this particular topics. So with that, we end section 1 on functions and function notation.